Hi folks, this is the last part of the short video series discussing the wind scale side of the flight computer. At the end of the last video, we had added the wind of 360 degrees, 30 knots to the wind scale side of the flight computer. And now we need to explore what effect this has on the aircraft's course across the ground. Let's start by looking at a simple case. The forecast wind is 360 degrees, 30 knots, and we want to track 360 degrees, i.e., all of the wind is acting directly as a headwind directly on the nose. If we visualize a situation, it's pretty clear that because the wind is directly on the nose, there will be little, if any, directional drift. Still, it will mean that if the aircraft's true airspeed is 100 knots, then the ground speed will be 100 knots minus 30 knots equals 70 knots. And that's because the air mass in which the aircraft is moving is itself moving with respect to the ground. This can be seen diagrammatically in the image where I have rotated the inner ring and hence the transparent wind scale window so that our required track of 360 or north is aligned with the index mark. This results in the X mark resting over the 70 knot speed arc. Now let's look at the case where our required track is, for example, 090 degrees. We rotate the inner ring so that 90 is aligned with the index mark. If we now read off the drift, the X mark is aligned with the 16-degree drift line on the drift STBD or drift starboard side of the flight computer. This makes sense because if the aircraft is pointing 090 due east and our wind is coming from 360 due north, it will be coming from the left-hand side and pushing the aircraft right in a starboard direction. What this means is that if we point the aircraft at a heading of 090 with a 360 degrees 30 knot wind, we will actually track 090 plus 16 degrees, 106 degrees. But we don't want to do that. We want to track 090 degrees. So let's change the direction the aircraft is pointing to head into wind. 090 minus 16, 074 degrees. We rotate the inner ring so that 74 is aligned with the index mark. Now that looks a bit better, but if we look closely at where the X has ended up, we see that it is now 17 degrees right or starboard drift. That means that if we point the aircraft at a heading of 074, we will track 074 plus 17, 91 degrees, and not 090 degrees. Okay, so let's refine this initial estimate and head at 073 degrees. Rotating the inner ring by such a small amount changes the drift by less than 1 degree. Good enough for military work, as the saying goes. So if we now point the aircraft at 073 degrees, we will track 073 plus 17, 090 degrees. Perfect. The final solution is shown in this image. Lastly, if we look at where the X mark has ended up, we can see that it remains on the 17-degree drift line, as well as being on the 96 knot speed arc. So our ground speed will be 96 knots. This completes the calculation, and we can say that if we want to track 090 with a true airspeed of 100 knots and a wind speed of 360 degrees, 30 knots, we will need to have 073 degrees, and the resulting ground speed will be 96 knots. You may find there is a slight variation of plus or minus 1 knot due to inaccuracies in your marking of the wind on the wind scale side of the computer, or the measurement uncertainty due to tolerances in the flight computer manufacturer itself. These are to be expected and acceptable. The last thing I want to say about the wind scale side is that it becomes easy with practice. You can do this by using BGS Question Bank or setting yourself questions and checking the answers with one of the many online wind vector calculators. Google is your friend here. Try searching with the term E6B calculator. That's all for this video. See you in the next one.